So here is question number 11, everyone. Two plane mirrors are inclined at an angle of 70 degrees with each other. An object O is placed between them as shown in figure. Select the incorrect option. We have to select incorrect, not correct. So number of images we have to calculate. N is given by 360 upon theta if object is not kept symmetrical. So 360 upon theta, that is 70, gets you 5 point something. N equals 5 point something. We remove the fractional part and therefore we will get the total number of images as 5. Option number 1 correct, but we have to pick the incorrect one. Now number of images formed by M2 and M1, this is also we have to talk about. So here is suppose mirror M1 and this is mirror M2. The first image will be formed right here, making the same 30 angle with M1. The first image of O due to M2 will be formed right here, making the same angle 40 degree from mirror 2. So 30-40 combination we have got. Now next, see this first image due to M1, that is I1, will act as object for M2. So now this I1 from M2 will be what? 40 plus 30 plus 30. That is for M2. This I1 is now object for M2 and lying at an angle 100 degree. Similarly, this I2 will act as object for M1. I1 acting as object for M2. Similarly, I2 is acting as object for M1, making angle 40 plus 30 plus 40, 110. Now see, 30 is raised by 70, you are getting 100. 40 raised by 70, you are getting 110. You have to follow the same pattern. 30 plus 70, 100, and 100 plus further 70, 170. So third image of M1 will be formed at an angle 170. On the other hand, the third image due to M2 may be formed at an angle 110 plus 70, that is 180. 180 degree. It means what? If this is mirror M2, then image is right here, which is quite not possible. So that is why this we cannot take. We can take these 5 values. So M1 is forming 3 images, M2 is forming 2 images. Now let's read the option. Total number of images formed by M2 is 2, absolutely correct. Number of images formed by M1 is 3, this is also correct. 4. Number of images formed by M1 is 2. Yes, we have to pick the wrong option, so we will go with option number 4. Option number 4 we can go with, absolutely correct. Now move on to the next, that is 12 number. So here is question number 12, everyone. The equivalent resistance of circuit across AB is what? Where diodes D1 and D2 are ideal. So see, 2 values are given. It means what? It means we have to take both the cases. If diode is forward biased, total resistance. If diode is reverse biased, then also total resistance. So first of all, let us talk about the forward biased. In forward biased condition, we have diode is ideal, so that's why short circuited. Three, 6, 9, 18, and this is 4. Wheatstone bridge condition is right here, so that's why the net resistance we can write 9, 3, that is 12, 6 and 18, that is 24. 12 and 24 are parallel to each other, so the combination is 12 into 24 upon 12 plus 24. Solving it gets you 8 ohm. So this is one possible value. Now let's talk about in reverse biased. In reverse bias condition, the diode will be open circuited and the equivalent circuit can be like this. that is 6, 4 and 19. All of them are in series connection. So that's why net resistance is what? 19 ohm. 6, 4, 10 plus 9, 19. So the possible values are 8 and 19 ohm. Option number 3 we can go with, which is absolutely correct. Now move on to the next, that is 13 number. So here is question number 13, everyone. A body of mass m is released from top of wedge which is free to move. If all the contact surfaces are smooth, then the velocity of wedge on reaching the body at the bottom of inclined is what? Initially the body is at this position, kinetic energy is 0, and because speed is 0, potential energy exists, and it is mgh. Once body slows down, what happened? After reaching at this point, the wedge started to move. Suppose velocity capital V, it has velocity small v. Mechanical energy would be conserved, and we can write half mv square plus half capital mv square equals mgh. Solving it, we get half capital M capital V square will be what? mgh minus half small m small v square. Looking at this equation, what we can say? We definitely can say that half capital mv square is less than mgh, as there is a subtracting factor. Therefore we can write v square, capital V square will be less than 2 mgh divided by capital M. Therefore V will be less than under root of 2 gh multiplied by small m upon capital M. Now we have to talk about the velocity of wedge. Here capital V is the velocity of wedge, which is depending upon m by m ratio. V depends upon small m upon capital M ratio. So that's why sometimes it can be greater, sometimes it can be less, and therefore we can go with option number 4, which is absolutely correct. Now move on to the next, that is 14 number. Here is question number 14, everyone. 2 point masses are connected by light rigid rod as shown in figure. The minimum value of moment of inertia of the system about a line perpendicular to the length of rod will be what? We know very well moment of inertia I will be minimum along center of mass. Along center of mass. So suppose center of mass is existing right here. So we have to calculate the moment of inertia about this point, that is IC. First of all, let us find out where the center of mass is lying. So taking this as origin, and this is our x-axis. So RCM will be what? M1x1, that is 2m into 0 plus m2x2, that is m into r, divided by total mass, that is 2m plus m, 3m. R by 3 will be where the center of mass will lie. So this is R by 3. So this must certainly be 2R by 3. Total moment of inertia about center of mass IC will be what? M1R1 square plus M2 R2 square. M1 is 2M. R1 is R by 3, so R square by 9. M2 is M. R2 square, that is 4R square by 9. LCM same, 2mr square plus 4mr square, that is 6mr square. 2 by 3. So IC finally we have got, that is 2 by 3mr square. And after looking at the options, we can say that option number 2 is perfectly matching. So we can go with option number 2. Now move on to the next, that is 15 number. Here is question number 15, everyone. A short electric dipole having dipole moment P are kept on the corner of rectangle as shown in figure. The direction of electric field at the center O of rectangle will be what? Now we have to talk about the direction only. not magnitude. So this is P. Let us break the component of this P. One will be right here in this direction, and another component will be along the diagonal, means in this direction. If I'm taking this as angle theta, then this component will be P cos theta, and the next component of dipole moment, that will be P sin theta. Now the electric field at point O, we are having two component of electric field as well. One will be due to P cos theta component, that is lying XII in this direction, taking is as E1. Another will be this P sin theta dipole. For this P sin theta dipole, the point O is at equatorial position, and the electric field will be opposite to dipole moment direction, that is right here. This is E2. This will also be angle theta, 90 minus theta, and this is theta. So this is all about the diagram. Now you know very well, suppose this separation is R, therefore E1 can be written simply 2kp cos theta divided by R cube. On the other hand, E2 can be written as K, dipole moment is P sin theta, so Kp sin theta upon simply R cube. Equation 1 and equation number 2. Now let us calculate the net electric field in X direction, which can be written as Ex. So student, Ex can be written as E1 cos theta minus E2 sin theta. Putting the values of E1 and E2, let's see what we are going to get. E1, that is 2kp cos theta upon R cube. One more cos theta is there, so here it will be cos square theta, minus E2 is kp sin theta upon R cube. One more sin theta is there, so sin square will be here. Taking the things which are in common, that is kp upon R cube. Now what we are going to get? 2 cos square theta minus of sin square theta. Now let us talk about the angle theta. See, in this particular rectangle, this is root 2L, so half will be what? L upon root 2. This is L, so this length will be L by 2. Now look at this triangle, theta, L by 2, L by root 2. Tan theta we can write perpendicular upon base, that is L upon root 2 divided by L by 2. Solving it gets us tan theta, that is root 2 by 1. Now from here we can calculate sin theta as well. If I am taking a right angle triangle kind of something, tan theta is root 2, means perpendicular root 2 base 1. Hypotenuse will be what? Under root 2 minus 2 plus 1, that is under root 3. So from here we can write sin theta and cos theta. Sin theta will be perpendicular upon hypotenuse, that is root 2 by root 3, and cos theta will be base upon hypotenuse, that is 1 by root 3. Putting the value of sin theta and cos theta from here into the final equation, what we are going to get? Ex will be kp upon R cube 2 into cos square theta, that is 1 by 3, minus sin square theta, that is 2 by 3, gets you 0. So now we can write, since Ex is 0, it means the total electric field, the net electric field, is along y direction. Therefore electric field is along negative y direction from the diagram. Some here, this will be E. So we can say that option number 4 is absolutely correct. So we will go ultimately with option number 4 only. Now move on to the next, that is 16 number.